Hi, welcome to Addressing Security Concerns in Every Stage of the Software Supply Chain. My name is Melissa McKay. I'm a developer advocate at jfrog. And just some quick background on me. For the past, over 20 years now, primarily I've been a developer, all the way from a lowly intern to a principal engineer. And the last few years of my career as a developer advocate, I've been going to conferences, talking and sharing about these experiences. A lot of this talk will be that exactly, just things that I found over the course of my time as a developer. And my contact information is here if you have any questions, and I'll share that with you again at the end. So one of the things that I've been able to do as a developer advocate is have a lot of interactions with other people that work at other places, deal with lots of different things. And one gentleman I had the pleasure of meeting and working with was Damian Curry. He is the business development technical director at F5 and with nginx originally. And with him, we decided to get together and just kind of explain the journey of an application. Basically, what we wanted to talk about was a series of just going through each of the stages that you plan for and discuss as you're running through all of this necessary steps that you need to take to get a application all the way from just the very beginnings of development all the way into production. And we have a list of episodes that we've created, each of them varying time, maybe 30, 45 minutes each. And the one that was really interesting was the one where we considered security. This talk I'll be focusing more on in this episode or in this talk. It was really interesting to get a developer's perspective, myself, as well as an ops perspective on this, which was more in Damian's field. So I don't know how many of you have seen this. This is just a typical default web server page. And way back, this was my very first experience even thinking about security. During my time, in school and when I was learning in the very beginning as a junior, it just didn't cross my mind how many things we need to be concerned with, in addition to just writing good code. But there's other things about our environments that we really need to pay attention to as developers. And one thing that was introduced to me was security through obfuscation. I can't even say that word correctly. And this was funny because, we can go on and on about whether this is a good strategy or not. It was my first experience touching on security at all. So basically, my first step was to go through and make sure that this default page didn't show up, because we didn't really want to reveal what version of Apache we were using, just in case someone had any clever ideas of attacking that particular version. So obviously, lots of reasons to be concerned with security. All over the news, we hear about theft of private customer and or company data. I just got a letter in the mail, as probably a lot of you have gotten, from various banking places and other, places that use my credit, things like that. So lots of reasons and lots of money in this business. Talking about that, the loss of money for an organization if they're not taking their security seriously or they suffer from some intrusion, there can be a loss of money, not only on their side, but on their customer side, and also loss of credibility. We can all agree that downtime as well, for any reason, is a problem in your production environment. So yet another reason to be concerned with security issues. I'm just going to whip through some famous hacks. This one, probably most of you are familiar with, the Equifax data breach. This happened March through July of 2017. And there was a lot of money involved in this. 1.4 billion in cleanup costs estimated, 1.38 billion in consumer claims, and 143 million customers were affected. For those of you familiar with this was an Apache struts vulnerability. Unfortunately for this company, this was a vulnerability that was known, but just wasn't patched in time before something happened. So what happens in a nutshell on this next one, log4shell, is that one can trigger a remote code execution by providing a string in a certain format that ends up being logged. And it turns out that opens up the ability to initiate an LDAP lookup, fetch some compiled code, and execute it. And just about every Java developer out there cringed their way through fixing this vulnerability. It took a lot of time, lots of money as well. When we're talking about money, we're not talking about just claims. We're talking about the time that developers need to spend and ops needs to spend fixing these problems. Stephen Miguel the vice president of product innovation at Sonatype, he estimated that approximately 70,000 open source projects use Log4j as a direct dependency, and 174,000 projects use it as a transitive dependency. That means a dependency of a dependency. All right, here's another one. This is just interesting to me. I just went looking just to see what the most recent attacks were. We hear this stuff in the news all of the time, kind of depressing. A lot of these have to do with data breaches. And this website attracts the latest data breaches. It's, of course, a huge motivator for hackers due to its immense value. And there's several of these each month. And there's already some new ones that have come out, but there were a few that really caught my attention, mainly because of the commonality of the moveit hack between all of these. So in June 1st, 2023, the moveit hack affected Zealous, British Airways, BBC, and others. It's a popular file transfer tool. Again, in July 20th, it reared its ugly head. There was a PokerStars data breach. This is the world's largest online poker platform, and it suffered this data breach, which exposed the information of 110,000 customers. The attackers, they exploited that moveit zero-day vulnerability to gain access to the poker site systems. And they're no longer using the moveit transfer application, but there was a lot of data stolen in the meantime, unfortunately. Last one, August 11th, that I'll just point out, also in 2023, this was the IBM moveit data breach. There were 4.1 million patients in Colorado that had sensitive healthcare data stolen during another that exploited that same vulnerability in the moveit transfer software. The systems affected were managed by large companies like IBM. So this was serious business. There's a featured article on TechCrunch that was put out on August 25th. It described the moveit hack as the biggest hack of the year by the numbers. It's an interesting one to check out. Included a QR code here for you if you want to go read that yourself. The global average cost of a data breach was $4.45 million in 2023. That's a 15% increase over 3 years. This is serious business. So we do need to sit back and figure out what we can do to help mitigate these problems. And as a developer, it does sound reasonable to say that if you're developing software, you're writing software, it is your responsibility to write code that is secure. This is absolutely true, but as we talk a little bit further about this, there's something that you need to understand. It's not all about the code that's written itself. So just for fun, I discovered this essay, How to Write and Secure Code. For those of you that like sarcasm, you'll really enjoy this one. There's quite a few third-party organizations that can be hired by corporations to train their developers internally, and I'd highly recommend that approach. But if you're on your own learning these things, this is a really good research for you. Even just this essay itself, even though it's kind of a joke, there's some things in here that are really good to point out. And lots of detailed information on how to protect your systems, how to protect your container images, for example, the environments that they're running in. It's pretty amazing. And OWASP, the Open Web Application Security Project, that's where this essay is. That's the resource that has a lot of this information for free. So there's a lot of opportunity for you to go out and learn on your own. Some of the things that were included in this essay I thought were important to point out. Always using default deny. This is kind of silly. Denying that your code can't ever be broken. Deny unless there's something that can be proven that it's actually broken. Just pretend that everything's fine. Secure languages, who writes in secure languages? I think, we all have a tendency to adore the language that we were brought up with. My background is in Java. I enjoy writing, a lot of Java. That's basically where I'm most familiar. But we all know that all of our languages have pros and cons, and there's some things that we need to pay attention to, some weaknesses that we need to learn. Mixing different languages. This is kind of funny. I being a Java developer, it's important to point out that these days, rarely are you going to find a Java developer where all they program is in Java. There's lots of other languages that you need to learn in order to get things like web apps out there. be able to write, scripts in shell, things like that. Lots of Python these days. There's a lot of opportunities to learn and work with other languages as well. And one of the jokes in this essay is that if you mix as many as possible, you'll be fine. They all have different security rules, so it'll be difficult to break into any of them. Pretty silly idea. A few more before I just let you go read the rest on your own. Relying on security checks done elsewhere. This is a big one for developers, right? Because we're on teams. If you're in a larger company, you may be on a team that has a whole nother separate security team that is dealing with a lot of these issues. So it's easy to kind of sit back and think that, oh, well, that's already being taken care of by someone else, so I don't really need to think about it. Obviously, learning about a security problem much later in the development process is a lot more expensive and difficult to mitigate than dealing with it or preventing it up front in front of the developer. So anything that we can do to help this process is valuable. And we do need to learn what is in our developers' toolbox to help us prevent some of these things from happening. Trusting insiders, malicious input only comes from the internet. You can trust that all data in your databases is perfectly validated, encoded, and sanitized for your purposes. Anyone who's been dealing with especially if you're switched back and forth between a production or a test system, you know that there's opportunity sometimes if you're allowed too many permissions, or maybe the systems aren't set up in such a way to prevent accidents. Obviously, you can get problems from within. It doesn't always come externally. Oh, and then code wants to be free, this last one. Dropping your source code into repositories that are accessible by all within the company. I used to, especially back when I was a junior, I used to want to have access to everything. I wanted to see everything, mainly just because I was curious, but oftentimes that's not the best. It's for your own protection to only have access to what you actually need to have access to. Being able to, update a repository or make changes to code that maybe isn't even in your project, not a real safe way to operate. And we have to remember a lot of times errors happen or issues happen that, it wasn't on purpose. It wasn't malicious intent. It could have been just an accident. So we have permissions to kind of give us some guardrails to prevent things like that from happening. All right, so educating developers is really important. I talked about this, and I was lucky enough to be involved with an organization that did have one of these third-party organizations that was hired to train us a little bit. And depending on your particular language that was your focus, you had some specialized activities to learn about all of these things. We had, learned about what SQL injection was, what cross-site request forgery was, what LDAP injection was, how to prevent these things. And after taking those courses, I really thought I knew my stuff. I thought, well, I'm going to write the most secure code ever. This is all I really need. And as long as I do that, everything's going to be fine. What I didn't understand at that time, and quickly learned thereafter, is even though I was confident in writing strong code myself, it turns out there's so much open source code that we use. Part of being a responsible developer is to not continuously reinvent the wheel if it's not required. Being able to go out there and find resources that you can build off of is going to help you get your applications out to production faster, deal with issues faster. If you have, these frameworks that work really well for you, you're going to be able to just develop your applications more efficiently. So it turns out there is a ton of code that you may not have ever written and may never look at and don't know much about, other than they are just the building blocks that you're building on top of. So it turns out there's a lot of code, like this iceberg picture, that is pulled in during your build that you've never touched or looked at before. And when I was working with Damien on our series, there was a little project we were working on. There was a number of different components, and I just did a Maven tree just to look and see what all of the dependencies were. And it turns out just in a single component that we were looking at, there were 114 direct and indirect dependencies, and they went 7 layers deep. So dependencies of dependencies of dependencies. And these were all just brought in as I was doing a build, from Maven Central. And again, that entire application consisted of 7 microservices. So this is, multiplied by 7. There are a lot of security reports out there that you can take a look at. This one is particularly interesting, Open Source Security and Risk Analysis Report. In this one, 1,703 commercial code bases across 17 different industries were scanned. And one thing when you're reading reports like this, always look at the methodology. This number is kind of buried in the report just to give you an idea of where this information is actually coming from. And I'm always impressed when that is, upfront for you to see. This one was. And they have a number of different graphs of the different industries. I liked how they categorized all of these things, because sometimes when we work in a silo, we don't realize all of the code that's being written everywhere in every industry. These three were pretty important. I just took these three graphs directly from the section on the use of the open source, and the three industries, that I thought were most interesting. Also interesting, and maybe this can be, a fun talk with your colleagues or whatever, is why there's such a peak in 2020. I can only imagine. Maybe the peak in vulnerabilities, I don't know if they're just more being discovered in 2020 or more being introduced. You can go round and round with your colleagues on that one. If every developer that writes code writes secure code and doesn't make, mistakes, then we shouldn't have any of these problems, right? And is it really all up to developers? And I think you already know the answer to that. There is a lot that we can do, but there's actually a lot that we aren't involved with, like the code that we've written. It doesn't matter how well we've written it. There's still some issues we need to be aware of. This is a perfect example of it. SolarWinds. So this involved 18,000 customers that received an update that included malicious code with a backdoor. And basically 44,000 lines of code was written to the Orion platform DLL, but it was done after compilation, which suggests that the binary may have been switched in the CI system internally. And what made this foolproof is the fact that that file was even digitally signed. So it's possible that attackers had access to the SolarWinds software development or the distribution pipeline. So after the code is written and sent off, to be built and then to be delivered, something happened in there. So it's just way more complicated than just developers themselves writing secure code. This is a corporate slide that I see often in decks within JFrog. And this, just kind of gives you a view of the world, of all of the environments that we work with, all of these components that we put together when we build our software. And you can see the whole process here of a developer initially writing code, pulling in packages and libraries from remote repositories or public repositories, going all the way through building it on your CI servers, whichever tool you choose to use. And I just want to highlight all of these red arrows everywhere where we refer to artifacts and dependencies. There's a lot of places in here that are weak points that if an attacker has access to, they can interrupt this flow and basically cause you to put out a vulnerability into production. One organization that has been, helping define all of these areas where there can be issues is the supply chain levels for software artifacts, SALSA. This is basically an attempt to measure an organization's progress and to help give them goals to improve, just to kind of give you, a baseline to start with and give you ideas on what different areas of your software development process you can improve. So between your source code and the delivery of your product or the deployment of your service, there are places you really do need to take extra care to protect your supply chain. And each one of these red triangles represents an opportunity for an attacker to disrupt. So let's talk about a few more examples of things that developers need to be aware of that we can have some control over. And one of these is called a dependency confusion attack. This was described by Alex Burson in a blog post on Medium a couple of years ago. It turns out that most projects have a collection of dependencies, and they include open source or publicly available packages as well as internal packages. And this example, the highlighted yellow, are internal package names. Note that the version requirements for these are just that the version is either the one specified or greater. These package names, when you build, are not secret either. It turns out that npm requests inform about internal package names. So what exactly is the problem here? Well, let's take a look at what it means in the diagram. A request is made for a corporate library, an internally built library, something that may be proprietary, and it's expected to come from some internal repository. But what happens instead is that the package manager sees that there's a greater version available publicly, and it will pull that one instead. So who knows what's in that package? Havoc ensues. You'll find out pretty quick, probably, or if it's something, maybe not. Maybe you won't find out pretty quick. It could be something running in the background that you don't see right away. So one way to protect yourself from a scenario like that is to control your requests for internal packages. And using an artifact management system, you can specify internal package requests to only be resolved with internal repositories. It's important to remember to do this because this isn't the default setup, right? By default, you pretty much have access to anything. I don't know, depending on how your organization works, you may be in a position where you don't have access to the internet, other than through proxies provided by your employer. You might be behind a firewall of some sort, but most of the time, especially when you're developing pet projects at home or in any other environments, you're going to be pulling directly from public repositories. So it's important to understand that that's what's happening and the default behavior of your build software, so that you know exactly where what you're pulling in, where it is coming from. This particular attack, $130,000. Alex did a really good job of employing himself with these bug bounties. There's quite a few details that he discusses in his article that I didn't talk about. So here's another QR code for you to read his original article about that. All right, here's another fun one. Managing open source dependencies. I think many of you, if you like XKCD, it's one of my favorite cartoons, you probably have seen this one. The problem has more to do with managing open source packages and libraries themselves, not really about a malicious package or a vulnerable package. It just illustrates a trap that we fall into when we solely rely on public repositories for our builds, things that other people have written. And the best example of where this problem rears its head is the left pad incident. Basically, a developer had an npm package out there named kick. And it was just a pet project that helped developers set up templates for their projects. It wasn't really widely known, but there was also a kick organization. It was a chat app, and they owned the domain kick.com. So they had trouble with this kick package being out there in npm because it just seemed like when someone wanted to pull in kick, they were expecting to get something associated with kick.com. Also, kick had a registered trademark on the name. So, there were some issues there. So they contacted a developer, tried to come to an agreement. They were not able to come to an agreement. So npm came in, and because of that policy of making sure that users get a package that they expect in order to eliminate, typo squatting, that kind of thing, they sided with the kick organization. And under that policy, usually what happens is the existing package with the disputed name, it stays where it is. It remains on the npm registry, but the new owner of that name publishes their package with a breaking version number. So that's what happened. But unfortunately, the developer unpublished his package. And along with that, 272 other packages that he wrote. So obviously, he was pretty miffed about the decision, did not support that at all. And one of those packages was left pad. This was a pretty big deal because it turned out that a lot of software out there relied on left pad, not even directly, but as a transitive dependency. So things were broken right away. There was a developer who stepped in, Cameron Westland, who published, in order to help with this problem, he published an identical version of the package, labeled it as version 1.0.0, but many of those pieces of software that relied on it originally were following best practices, and they were explicitly requesting version 0.0.3. So it was still a big problem. People had to figure out exactly where in the code that they were relying on this and make sure they were getting the right package. Now, the most interesting thing about that story is this is it. These are the lines of code that were an issue and caused so much trouble. And if any of you that deal or work in JavaScript, you might be familiar with React. React was broken because of this. That's widely used by and created by Facebook and used by Facebook. And many of these projects actually relied on Kik as a transitive dependency. So just a tiny little piece of code and such a big problem when it got removed from a public repository. Now, here's another one. I am a Docker captain, so I deal a lot with containers, but I do remember back when I was first learning how containers are built and combing through Docker files, there were a lot of issues that I didn't understand. I didn't know what was going on under the covers. And this file, this is a very contrived file, but something you might find when you're looking for examples of how to write a Docker file. And there's just a couple things that I'm going to point out here. I won't go through everything, but just a couple. So the first line, first of all, a lot of Docker images rely on base images. Where are these base images coming from? Think about that. They by default are coming from Docker Hub unless you are explicitly asking for it from another registry. So make sure you understand where your base images are coming from. There's a lot out there. There's a lot that that are trusted, that are well maintained. So make sure that you're using those. Also, there's no tag or SHA identifier. So I would argue that even a tag isn't enough to actually pin an exact version because it's more of a pointer than anything. It can be overwritten. A tag itself can be overwritten and you might get something completely different than what you were expecting. We see this a lot with when you rely on latest. You'll get the latest of the image. Sometimes that's appropriate. Like if you're in an R&D environment or something, you always want to get the latest build. But in other times in production, I wouldn't rely on the latest. I would pin that version down to make sure you don't get any surprises. All right, another one, lines 2 through 4. So these are packages that are updating packages in the base image. And you can see some don't have, line 3, there's no version number at all. Line 4 is a particularly old version. It could be bad. It could have a vulnerability in it. I see people discover this most often when a new developer joins the team and they are, building this from scratch on their fresh environment. They don't have the advantages of having a full cache already. And so they might come into a lot of different problems where some of these packages are coming in that are not the same as what everyone else has. So good to pin those versions down. What else? Next, line 7. So referring to external resources, this is just a curl script. There was a situation I once had where our team needed a proprietary piece of software installed. And so we just, we did exactly this. We, got the shell script that was provided by the company, brought it in, ran it. Well, what happened was it worked fine for a while, but then that company decided to move it or change it. The first thing that happened was it was changed to an incompatible version. Well, obviously that wasn't going to work for us. Next, it moved to a completely different location. So each of those times we had broken builds and we had to figure out what it was. So rather than rely on an external resource like this, the best thing you can do is to bring it in to your internal environment and manage it there. Make sure that updates, you have control of when it's updated or when it's moved rather than trying to coordinate with an external source like that. Lastly, number 9, images running as a root. This is big. I feel bad sometimes about saying that. It seems like an obvious thing now. It's talked about a lot, not to run images as root. Always, make sure that you pay attention to, obeying that policy of least privilege. But even in 2022, Sysdig puts out this report every year, this Cloud Native Security and Usage Report. They discovered that out of 3 million containers they were observing, 76% of them were run as root. Now, sometimes that's legitimate, but the important thing to know here is make sure you know why you're running as root. If you're just doing it by default, probably not a good situation to be in. I'm going to hammer on this a little more because there's a more recent report that just came out, and we're not getting better at this. We're getting worse. there's now 83%. This was out of 7 million containers that were being observed. 83% of these containers were running as root. So lots of problems. Is there any hope? Let's talk about some solutions, some things that we can put in, actual actionable items where we can improve our situation here. First thing, educate ourselves. I'm going to hammer on this a lot. I know that developers are already, we have a full plate. There's already a lot that we need to know. But as developers, we also understand that this is a career where you're constantly learning. Things are constantly changing. You constantly need to keep up. So adding things to your toolbox around security, extremely important. No one is ever going to know everything at first. So it's important to have a combination of teams where you have more senior folks on the team as well as juniors. It can be very difficult if all you have are juniors on your team. We really do need to work on mentorship and making sure that we're guiding the next generation up so that we don't fall into the same old traps over and over again. Some ideas for education. I brought this up earlier in the talk. OWASP resources. They have some cheat sheets out there on their website. There's a QR code for you here. All kinds of stuff that you can learn. All the things I mentioned earlier that I learned through a third party, things like cross-site scripting, SQL injection. They go through all of these things. A very detailed section on containers too, and environments for those. So always, very, very good references here for developers to take advantage of. Another one, the openssf organization has a trio of free courses. These three are part of the Secure Software Development Fundamentals Professional Certificate Program. So if you pay some money, you can actually get a certificate for taking these courses, but they also provide them for you to audit. You can audit these for free. All of them are available on the edX platform. So another easy resource for you to take advantage of. All right, I'm going to go through the rest of these pretty quickly. Don't rely solely on public repos. Remember the left pad incident that I talked about? That's one reason. I'm not going to say public repos are bad to use. Obviously, they're valuable. You need them to get the initial packages that you need, right? And that's our location for where developers can share open source software. Just make sure that you save every artifact that you need for your build in a local artifact management system, something that you have control over, that you can manage and take inventory on. And there's lots of tools out there. Obviously, my employer is JFrog. I could recommend Artifactory, but there are other tools available out there that you can start with that are open source even. The important point here is just to have one. Make sure that you're keeping track of your dependencies so that you don't have broken builds for unknown reasons. All right, manage your dependencies. Again, I recommend an artifact management system. Just have one. But make sure that you specify explicit versions in your software so you know exactly what packages that you are getting. And in the cases of Docker images, using a SHA, some of your NPM packages using a SHA is appropriate. So make sure that you're doing this. Manage permissions. So important. This is probably more controlled under an ops environment, but developers need to pay attention to this. They need to enforce least privilege access. That requires an understanding of which permissions are actually needed, that are actually going to be in use. And that brings me to the latest SysDig report as well. They pointed out that 90% of granted permissions are not even used. This is dangerous. It can set yourself up for not only malicious activity, but it can set yourself up for some serious accidents. Not a good thing to go through, especially as a junior developer, if you accidentally wipe out your production database, for example. So these are things that we need to be paying attention to. Okay, managing your dependencies, your permissions, that's not enough. You need to regularly scan your libraries and packages. It's not a one and done thing to say, oh, I brought in this package. It's good. I've got it stored locally. This is what I'm going to use forever and ever. Things come out all of the time. New vulnerabilities are discovered all of the time. So it's important to stay up with the latest. Make sure that you're regularly scanning them so that you discover them to begin with and have a process where your developers can fix these issues. And that involves keeping up with maintenance. So not only your packages need to be updated periodically, reviewed periodically, but your systems, the environments that your software runs in, they also need to be updated regularly. Don't let things get stale. And lastly, make sure you have a plan in place for when it comes time to dealing with a security threat in production, because it will happen. It will. It's important to have a plan that makes sense, where you can efficiently and quickly mitigate the problems, so you don't have a huge delay between discovering a vulnerability and then mitigating it with a patch. So having those automated systems in place, having CI in place, having automatic scanning in place, and then also being able to deploy a new version, making sure that that process is as clean as possible. So that's all I have for you. If you have any questions, feel free to reach out for me, both on Twitter or LinkedIn. I'm available in both places. And just remember that, there's always something new to be learned as a developer. We all go through that process, and these are just more tools and more awareness in your toolbox as a developer to make your projects more secure. Thank you.